Welcome everyone to this explainer. Today we're tackling one of the most crucial and, let's be completely honest, one of the most notoriously confusing topics in all of chemistry. Yep, we are demystifying the mole concept. It's literally the foundation for everything from basic lab reactions to creating advanced pharmaceuticals. But man, it fundamentally trips up almost everyone the first time they see it. Right off the bat, when you hear the word mole, what pops into your head? Are you thinking about chemistry, or do you instantly jump to complex, terrifying mathematics? Because the moment that word is dropped in class, so many people just freeze in sheer panic. You see those huge exponents, those intimidating formulas, and you kind of start wondering, what happened to simply mixing colorful liquids in beakers, right? Well, take a deep breath. By the end of this explainer, that panic is going to completely fade away. In fact, understanding this might just become your absolute favorite part of chemistry, simply because it suddenly makes everything else click into place. So, let's dive right in with a super familiar everyday example. If I were to ask you right now, hey, how many bananas are in a dozen? You'd immediately shout out 12, right? But why is that so automatic? It's because the word dozen is just a fixed counting unit for exactly 12 items. You don't even have to pause and do the math in your head. It's a grouped unit that we all naturally know and use all the time. Now, while we comfortably use a dozen for everyday items down in the market, the microscopic world requires, well, a slightly different approach. In chemistry, scientists desperately needed a special unit to count incredibly tiny particles, like individual atoms and molecules. And that special unit is called a mole. Just like we use a dozen in the grocery store to group 12 things together, chemists use a mole in the microscopic world to group a specific number of atoms. It's the exact same conceptual logic, just applied to a totally different scale. Okay, so if a dozen is always exactly 12, how many particles make up exactly one mole? Well, the answer is 6.022 times 10 to the power of 23. This is famously known as Avogadro's number. I want you to just take a second and truly think about the sheer scale of that value. That little 23 exponent, that means you are moving the decimal point 23 places to the right. It's a number so staggeringly huge that it honestly just breaks our normal human intuition. To put that into perspective, let's talk about what that number actually means in reality. Avogadro's number is so incomprehensibly massive that if you started counting these particles one by one, your entire lifetime wouldn't be enough to finish even a tiny fraction of it. Think about a simple, everyday glass of water. That single glass contains an absolutely unimaginable number of individual water molecules. Because atoms and molecules are so incredibly tiny and numerous, direct counting isn't just difficult, it is physically impossible for us. So how exactly do we handle things that we literally cannot count one by one? Well, imagine you walk into a grocery shop and you tell the cashier, hey, please give me exactly 500 rice grains. I mean, they'd probably look at you like you're out of your mind and laugh you right out of the store. It's a completely absurd request. But if you walk in and say, please give me 1 kilogram of rice, suddenly the job is incredibly easy. You get the exact amount of rice you need, but you used a much smarter, way more practical method to measure it. And you know what? The exact same thing happens in chemistry. This is the absolutely crucial point here. We do not count atoms one by one. It's just like the rice grains. Instead, we measure them using moles. The mole allows us to take a completely unmanageable quantity of tiny, invisible particles and translate them into a workable, measurable batch. We are shifting away from impossible counting and moving directly into highly practical measuring. Now, let's connect this whole mole concept directly with mass. This introduces a really elegant conceptual bridge called molar mass. Molar mass is simply the mass of exactly 1 mole of a specific substance. So, for example, 1 mole of carbon-12 has a mass of exactly 12 grams. That means if you scoop out exactly 12 grams of carbon, it contains approximately 6.022 times 10 to the power of 23 carbon atoms. The molar mass creates this beautifully simple bridge between the weight we can easily measure on a standard lab scale and the exact number of atoms we know are hiding inside. And this beautifully illustrates how we apply this to the elements and compounds we encounter every single day. Take oxygen gas, for example. That has a molar mass of 32 grams per mole. Or water, which sits at 18 grams per mole. Carbon dioxide, that's 44 grams per mole. What this actually tells us in reality is that if you pour exactly 18 grams of water into a cup, you know with absolute certainty that you have exactly 1 mole of water molecules right there in that cup. It's kind of like magic, right? It prepares you to instantly link everyday weight with a scientific particle count. Okay, now that we deeply understand the molar mass, I want to introduce you to what I absolutely love to call the golden formula. If you're prepping for exams, or if you just want to truly grasp how chemists do their daily work, this right here is your new best friend. Number of moles equals the given mass divided by the molar mass. And that is literally it. With this one beautifully simple equation, you can solve almost any fundamental mole concept problem that gets thrown your way. Let's actually put this golden formula to the test and see exactly how easy the mathematics are in practice. Let's say you get asked, how many moles are present in 18 grams of water? Well, our given mass is 18 grams, and from what we discussed just a second ago, we already know the molar mass of water is also 18. So we simply divide 18 by 18, and boom, we get exactly 1 mole. See? It's not complex mathematics at all once that core concept clicks in your mind. So, thinking back, was the mole concept really as difficult as it seemed? Or did it just sound scary at first? Chemistry becomes completely manageable, and honestly, incredibly easy when we connect it back to reality. The dozen, the kilogram, basic everyday counting. These are tools we use comfortably every single day without a second thought, and the mole concept relies on that exact same logic. The major takeaway here is absolutely clear. Don't just blindly memorize these formulas. Take the time to truly understand the logic behind them. As we wrap up this explainer, I want to leave you with an empowering thought. If your concept is strong, your numericals will never go wrong. I absolutely love the truth in that statement. Take a moment to really let that sink in. The microscopic world isn't something to fear. It's literally just waiting for you to learn how to measure it. So the next time you pour yourself a simple glass of water, ask yourself, are you just having a drink, or are you holding trillions upon trillions of tiny worlds right in the palm of your hand? Keep exploring, keep questioning, and I'll see you in the next explainer.